Hello friends, my name is Murad Waili. In this video I will explain in details the solution of the problem 1846 key resort from Codeforces. This is a problem statement. You can read it by yourself, but we can say it's roughly speaking. A teacher wants to go for at least k consecutive days of vacation, such as the temperature of each day is lower or equal than Q. So we want to compute the number of ways for the teacher to choose vacation dates at the resort. If I take a quick example here, for example, day number 1, the temperature is 2 degrees, here 0 degrees, day number 2. For day number 3 is 1 degree, let's take this one. And day number 4 is 4 degrees. Let's take a Q, the temperature that the teacher can support is maximum 11 degrees. So how many ways the teacher can choose? At least, let's take k is equal to 3 here, at least 3 days, consecutive days. He can choose these 3 days, or these 3 days. We say at least, so 3 days, and he can choose also all the 4 days. So the number of ways here is equal to 3, because these are 4 consecutive days, but the temperature is less than 11, so he can go on these days. We have consecutive days here. So, but he wants at least 3 days from these 4 days. He can choose on blue 3 days here, or on green, or on purple for all the 4 days. So number of ways equal to 3. Let's take this example here on the left. For L is equal to 14, we have 14 days here. K is equal to 3. See, so he wants at least go on vacation at least for 3 days. And the temperature we can support is equal to 11. So here, day number 1, we have 10. But here, as you see, the length of the day of the sequence is equal to 1. So the number of ways is 0 here, because he won't at least go on for 3 days. For 15, no, 20, no. So we have all these sequence here, all these days. We have this sequence: 5, 7, 9, 9, 8, 10 degrees for all these days. We have 6 days here. So how many ways he can go for at least 3 days here on this 6 days on the sequence? He can go for 10 ways. We have 10 ways he can choose his vacation or her vacation. Same for the last 4 days, because we have here 2, 0, 1, 4 less than 11. Same here, we have 17 here. We can choose 17 because it's larger than 11. So for these four days, as we have seen, the length is 4 here. We can choose. He has 3 ways to choose his vacation from these 4 days. So the total number of ways is equal to 13 for this, these 14 days. The logic of this, how we can build our logic here. Let's assume that every day is less or equal than Q, the maximum temperature that the teacher can support, by a green ball. We have 10, one ball there. Here we have 4, 5, 6 balls. And here we have 4 balls. So the question will be, if we have n balls, for example, the question, how many ways to take at least k balls from these n balls? Let's reduce the problem to this problem to make it more simple. Okay. Let's do this observation. Let's do observation here. For one ball, how many ways to take at least one ball? As you see, of course, here the answer is obvious. We have one way. If we have 2 balls, how many ways to take at least one ball? We can take this and this. We have 2 ways here, this and this, and all the 2 balls. So we have in total we have 3 ways, 2 for 1 and 1 for 2. How many ways to take at least 2 balls? We can take them all now. Well, I have just one way. Let's take for 3 balls. How many ways to take at least 1 ball? We can take this one, or this one, or this one. So we have 3. How many ways to take at least 1 ball also? We can take at least, we can take 1, 2, or 3. We can take these 2 balls or these 2 balls. So we have 2 here. Or we can take all the 3 balls. We have one way to take all the 3 balls. So we have 1 plus 2 plus 3 is equal to 6. So we have 6 ways to take at least 1 ball from these 3 balls. How many ways to take at least 2 balls? We can take these 2 balls or these 2 balls. We have 2. Or all the 3 balls. Just one way to take 3 balls from 3 balls. How many ways to take at least 3 balls? To have just one way to take 3 balls from 3 balls. For 4 balls, how many ways to take at least 1 ball? We can take this ball, the second, the third, or the fourth. So we have 4 ways here. Or we can take at least 1. So we want to take 2 now. These 2 or these 2 or these 2. So we have 3 ways here. For 3 balls now, 3 from 4, we can take these 3 balls or these 3 balls. We have two ways. Or we can take all the 4 balls, all of them, just one way. So we have here 10 ways. 10 ways to take at least 1 ball from 4 balls. How many ways to take at least 2 balls? We can take these 2, these 2, or these 2. So we have 3 here. Or we can take 3 and 3. We have 2 ways here. Or we can take all the balls. We have 1. How many ways to take at least 3 balls? We have these 3. 3. We can take 2 ways here. Or all of them we have 1. So 1 plus 2. How many ways to take all the 4 balls? We have just 1. As you see here, we have, after we have done with this observation, we can say that we have a pattern here. As you see here, 1 plus 2, 1, 1 plus 2 plus 3, 1 plus 2, 1, 1 plus 2 plus 3, 4, 1 plus 2 plus 3, 1 plus 2, and 1. Of course, it makes sense that the number of ways will definitely depend of depends of the length of the number of balls, or the length of the sequence, and k, the at least k balls, the number k. Let's take this example. For example, here we have 4 here, as you see, and 3 and 2, and every time we have 1 plus 2 plus 3 plus this number. How we can find this number? This number, as you see, 4, for example, here is 4, okay, which is the length of the number of balls, the length of the sequence, minus 1 plus 1. Let's say this is k. Of course, I have this reflection after, not immediately, after 15 or 10 minutes. I get this reflection after done all this observation. Now we want to make a formula. So here 4 minus 1 plus 1. Let's take for 3, for example. Here we have at least 2 balls. So it will be the length of the number of balls minus k, which is 2, plus 1, which is equal to 3. 2 plus 1 is equal to 3. For 3 balls, 4 minus 3 plus 1. For 1 ball, or at least 4 balls, we have 1 ball, so it will be 4 minus the number of balls we want to take, 4 plus 1, so it will be 1. So here this is 1, this is equal to 2, this is equal to 3, this is equal to 4. And after we have found this number, we can do all the sum from 1 to 4. Here the sum from 1 to 3, here the sum from 1 to 2, here the sum from 1 to 1. Let's see if this formula fit with the other examples here. For this one, for example, we have the length of the sequence is a 3, at least 1 ball minus 1 plus 1, okay, is equal to 3. For 2, it will be 3 minus 2 plus 1 is equal to 2. This one. For 1, 3 minus 3 plus 1 equal to 1. Okay, so we can say that if I have m balls, for a consecutive sequence balls of length L, the number of ways to take at least k balls is 1 plus 2 plus 3 plus 4 plus L minus k plus 1, which is this one. We know this. The sum of the consecutive integer from 1 to n is equal n plus 1, or n times n plus 1 over 2. N here is equal to L minus k plus 1. So L minus k plus 1 is equal to L minus k plus 2 times L minus k plus 1 over 2. Of course, we have to prove this formula. We can use, I will not bother you with the details here, guys. We can use the proof by induction. Let's take the statement PL for L balls. The number of ways to take at least k balls is this formula as we have seen. The base case for P1, we have seen for P1, for 1 ball we have 1 way. The inductive step, we're going to assume that PL is true. We have to prove that PL plus 1 is true. So I will make this computation. I have to subtract PL plus 1, PL from PL plus 1. I will find this expression. We can verify this formula, which means the difference between PL plus 1 minus PL is equal to L minus K plus 2. let's verify quickly from here. Okay. Let's say for k is equal to 1. K is equal to 1. So from 1 to here, from PL is L plus 1. So the difference will be L minus K plus 2, which is 1 minus 1 plus 2, which is 2. Which means the difference between this and this is 2. Is correct. Let's see between this and this. For K is equal to 1, this is equal to 6 here. This is now, this is L plus 1. Okay, the difference will be L, which is 2, minus K is equal to 1 plus 2. The difference is equal to 3 between this one and this one. It's correct, you see. Last one, here we have 10. The difference here, this is L now, this is L plus 1. We have L3 minus 1, K plus 2 is equal to 4. That's correct. You can verify for K is equal to 2, K is equal to 3, and add 5 balls here, and we will see that this formula is correct. This is our proof by induction. Okay, let's go to the solution now. Let's see how it will work. First, we need a variable to compute the length of each segment and the variable for the final answer. We start from the beginning. Here we have 10. 10 is less than 11, which is the maximum temperature that the teacher can support. Yes. So we add 1 to L. We go to the next temperature, 15. 15 is less or equal to 11. The answer is no. So here we're going to check if L is greater than K, L1, K3, the answer is no. So we do nothing here except we have to initialize or reinitialize the L2 to 0. We go to 20, same for 20, we have nothing here. L is equal to 0, greater than K, the answer is no. Why is greater than K? Why is greater than K? We have to see this. We have to check this because we want at least the length must be K, at least K. The length so must be greater or equal than K. The answer is no. Initialize L to 0. We give to 5. 5 is less or equal to 11. The answer is yes. Add 1 to L, as you see here. We go to 7. 7 is less than 11. Yes. Add 1 to L. It will be 2. We go to 9. Is 9 less than 11? The answer is yes. Add 1 to L. It will be 3. As you see here, we are building the we are computing the length of the sequence. We'll go to the other 9. Yes, 2. We have the length 4 here, the sequence at this point. We go to 8. 8 is less than 11. Yes, we add 1 to L. At this point, the length of the sequence is 5. We go to 10. 10 is less than 11. Yes. So the length of the sequence is 6. We go to 17. As you see, 17 is less than is 17 less than 11. The answer is no, of course. So we have to check is the length, the computed length now, the previous sequence, is greater than k? The answer is yes. L is equal to 6, k is equal to 3. So what we're going to do here, we're going to compute the answer using our formula. So the answer first is equal to 0. We're going to use our formula 6 L minus k plus 2 times L minus k plus 1 over 2, which is equal to 10. So the answer now for now is 10, which means for this sequence from 5 to 10, we can make, the teacher can make 10 choice to choose at least from these 6 days. At least he can choose 3 days. The number of ways is 10. And we have to initialize L to 0. We go to 2. 2 is less than 11. Yes, add 1 to L. 0 is less than 11. Add 1 to L. 1 is less than 11. Add 1 to L. 4 is less than 11. Add 1 to L. And as you see here, we have a problem. For this sequence, it will not be computed because we are at the end of the sequence here. What we can do here, we can do 2 or 3 ways. The perfect way that I have, or not the perfect way, I don't know. What I did here, I add the length is 4 here, for example, for this. I add an additional number at the end of the array. It must be greater than q. We can add 1 to q plus 1, which means 11 plus 1, which means 12. Why? Because we ensure to be sure that that at that day or at that number, it will not be computed as a sequence because it will be greater than q. So now we can continue to that number, 12. Of course, 12 is less than 11. The answer is no, is not. So L is greater or equal than K. L is equal to 4, K is equal to 3. The answer is yes. So we compute the answer. 10, the previous answer, plus the new computation, 4 minus 3 plus 2 times 4 minus 3 plus 1 over 2. The total will be 13. So the answer will be 13 at this point. Okay. And we initialize L to 0. And as you see here, all the computation is done. The code, this is the C++ code. But here, guys, first, I didn't write this instruction. I get a output in the Codeforces like this, which is of course a wrong answer for the judge. Okay. To fix that, I add this instruction, fix it, and set precision to 0 for the output. I'll fix it by fix it and set precision. So for each after this input, the function solve will take as parameter the array A, the number K, and the number Q. Before all the stuff we have to add a number greater than Q at the end of the array to be sure to compute the last sequence. Of the last sequence is all the days is less than Q. Then here we compute L, the length of each sequence. If the current number is less or equal to the Q, we add the 1 to L. Else we check if L is greater or equal than K, so we compute the answer. and we initialize L to 0 to compute the next sequence, to be ready for compute to the next sequence. And at the end, we return the answer. I hope this explanation help you to how to deal with this kind of problems where we require a math logic here. Thank you for watching, guys.